Hi everyone, my name is Hui. Today our group will be presenting on analysis on confirmed global COVID-19 cases on the team of analysis and healthcare. Our group consists of 5 members. They are Daryl, Diana, Joanne, Brandon, and me. I will be presenting on the executive summary of our project. Starting from the end of year 2019, the world is affected by a new disease called coronavirus or COVID-19. The spreading speed of the disease is terrible. Hence, the real-time data analytics is important to track the pattern of the disease spread and also able to predict the impact of the COVID-19 among the world. Our project is to study the data of the spread of COVID-19, predict the future number of confirmed cases, and also the trend of pandemic over 190 countries. We also collect the data from a website called GitHub and process the data in RStudio. In addition, we also plotting the outbreak disease spread on a worldwide map. Lastly, we believe that based on the analyzed data and worldwide map will be helpful in analyzing and predicting the pattern and the number of confirmed cases in future. It enables the government to take action and curb the spreading of the disease. By plotting the data, it will give you a clear view on what is going on and the trend of the pandemic. This will be easier for us to predict the data. That's all from me. Thank you.
Hi, my name is Darius Kareng, and today I'm going to be talking about our problem description of our data science project. So our problem description contains two goals, which is business goal and technical goal. So firstly, I'm going to be talking about our business goal, and the first one is to find out the data of confirmed global COVID-19 cases which can be implemented into our project analysis and predictions. And analyzing these data enable us to understand the scale and impact of COVID-19 globally. And also we aim to obtain information and examine the pattern of COVID-19 spread throughout the globe. And lastly, it plays an important role by using data analytics and data visualizations in helping healthcare professionals to control and monitor the possible spread of the disease. And moving on, I'm going to be talking about the technical goal of our problem description. So our technical goal is to, of course, find out the pattern of the global data of confirmed COVID-19 cases in selected countries and regions. And second one is we want to make predictions of confirmed cases across the globe, and we will want to able to recognize the pattern of the outbreak and how it is spreading throughout the world. And lastly, it is to identify the infectivity rate of the virus and conditions in different parts of the world. And that is all from me. I'm going to pass to the next person to be talking about the data description.
Hi, I'm Joanne. I'm going to present the data description of this project. So our dataset is come from CS Ferguson data in GitHub, acquired daily COVID-19 data from the area of the world countries since January 2020 to February 2021. There are 195 countries involved in this dataset for analysis. Hence, the dataset is used to determine the prediction of daily COVID-19 cases in all countries. There are 403 attributes in the dataset and separate into 5 main categories, so each attribute plays their important role in defining each of data present in the dataset. The first one is province and state, which is a string that indicating the name of specific area in the country. Next is country and origin, so it's a string that indicating the name of the country. The third one is latitude, the y-coordinate of the location, and also the longitude, the x-coordinate of the location within the city. Also for the date, from 22nd January 2020 to 34th February 2021 is the number of new cases in the date. Next is about data quality and limitation. So we hope to forecast the pattern of daily COVID-19 cases to help in determining and finding ways to predict and lower the new case. There is a big complication when dealing within the data, as data is too many and consists of many countries, hence we only can do an overall prediction compared with detailed prediction into each country area. To analyze and work with large amount of data, which is 110,422 data in the dataset, will lead to less redundancy and affecting the result of the accuracy. To avoid this problem happen, we need to choose specific features that need in the project. For example, our project focuses on daily COVID-19 cases in the country, so the latitude and longitude of the country will not be the important features in this project. Besides, the limit category of the attribute in the dataset make our analysis more simple and easier. So the prediction of confirmed COVID-19 cases in the country can be extracted from the dataset.
Hey everyone, this is Brendan. So next I'll be talking about the data preparation. So there are 5 steps during the data preparation. So the first step is by gathering the data. In this step, we gather all the relevant information. In our case, we use GitHub, which is the most reliable source of information that we could obtain from the project. So the next step will be discover and access the data. In this step, we discover the data that is involved during the analysis of the data and identify what is needed to be done to make the data useful. The next step will be cleanse and validate the data. In this step, it is the most time-consuming step in data preparation step, as it removes all duplicate data, filling the missing values, confirming data to the standardized pattern, and masking private and sensitive data. So the next step will be transform and enrich the data, as it updates and the format and value entries to a well-defined outcome so that the data is more easily understandable. And the final step will be storing the data. It is where data is being stored in the third party and clears a way for processing and analysis to take place. Thank you.
Hi, my name is Diana and I'll be presenting about the codes for data preparation. First, we have to load the data into our studio, and we made some adjustments, such as if the subject is cases, we are going to read from this file that is from GitHub. Then we can view the data. If you view the data, moving on, the dataset needs some adjustments, so we are changing some of the columns as characters, and we are going to load the library shape, and we use the data transform melt. Next, we are going to change the date format according to month, day, and year. Use the solution part, as we are going to aggregate the dataset and data subset countries. As you can see here, I've made data subset countries and data subset table. Now we are going to create data model that is up to 2 weeks. And we can see here, the number of cases have slightly increased between 15 February 2020 until 1st of March. Not only that, we are going to predict the number of cases globally that is using this line of code. So the number of cases today, this will be the number of cases. Next, we load 2 libraries. We're going to plot the number of cases so we can see it visualized. You can see that the number of cases have slightly increased. Not only that, you can also plot the whole n by using this line of code, and it shows that the cases are increasingly steep. Next, we are going to analyze a country that is for now is US, as we point the needle to US. Plot the graph of the US. It shows that the number of cases in US slightly increased. Not only that, we are going to investigate our country, Malaysia. So I'm going to put the needle at Malaysia. So we are going to plot the graph of Malaysia. So you can see here, the number of cases in Malaysia is also increasing. I can also predict the number of cases that will be produced in Malaysia using this set of code. Let's run it. The number of cases in Malaysia that will be predicted is around 30,000. I can also predict number of cases that will happen 7 days after, and predict the number of cases that will happen in the next 14 days. I'm also going to plot the whole time span of Malaysian cases. So the number of COVID cases of Malaysia increase over time. Not only that, I'm going to predict the number of countries that will happen, the number of COVID cases that will happen in China, Malaysia, Germany, and Iran. And we are going to plot the whole cases we can see here. We are going to create a regression of Malaysian cases for new infected cases using correlation and pairs. The correlation of cases and new infects is, as you can see, the probability is represented 1 and 0.24. As you can see, if we run the code pairs, we're going to see this diagram shows that number of cases is strictly increasing. If you use the summary of data subset countries, we are going to see the minimum, first quartile, median, third quartile, and maximum for the number of dates and the number of cases. That is all from me. Thank you.
In conclusion, based on the data analytical and prediction we made, we are able to determine and understand the pattern of the disease spread in a single country and globally. Therefore, the line graph, scatter plot, and many more graphs are shown from the cleansed data. We solely believe that with our analysis and predict data will enable to assist each country to know the trend and situation of the COVID-19 cases, and the highest authority should come up with some suitable prevention plan and action to curb and stop the spread of the disease. For example, action plan was taken by Malaysia government to curb the disease spread even worse in MCO, which is Movement Control Order. That's all from our group. Thank you.